This is section 6.5, Special Factoring Techniques. We just talked about a difference of squares for this problem. Now let's look at k squared minus 18, and we want to check to see if it factors. Our first step is to see if we have a GCF, and we do not. There's nothing that factors out of k squared and 18. We do not have 4 terms. We do have 2 terms. So that sends us off to look at a difference of squares. So the first thing I check for when I have, or think I might have, a difference of squares is to see if we have a minus sign in the middle. And we do. Okay. Then we check to see if each of these is a perfect square. K squared, obviously, is a perfect square. Now 18. Let's look at these. 18 is between 16 and 25. This is 4 squared, this is 5 squared, there's nothing between those. So 18 is not a perfect square. Okay. So that means that our answer here was no, we weren't able to do this, and that sends us down to this diamond here, where we ask ourselves, were we able to do anything? Were we able to factor out a GCF? No. Were we able to use factoring by grouping? No. Is it a difference of squares? No. Was it a perfect square? This actually right here, I have binomial written here. Technically that should be trinomial. And the reason I messed those up is because in this section it's called a perfect square trinomial. In the previous it was a square of a binomial. I just mixed those up. I'm going to try to remember to fix this. But this should also be fixed right here. Actually, I don't seem to have it written anywhere else. No, right here. Trinomial. Okay. Were we able to do that? No. And we also didn't do 6.2. Basically, we went through this whole chart and we weren't able to do anything. Since we were not able to do anything, we have a prime polynomial and then we are done. So this answer is prime. We weren't able to do any kind of factoring on it, so it is prime. Okay, so let's look at this one. 9r squared minus 4. So what we're looking at here is we have a binomial, and if you get ahead of yourself, you already see that you have perfect squares. But you always want to remember to check for GCF first. Is there anything that divides evenly into both of these? And the answer is no. All right, one more thing I want to point out is that in this course, if you have a number in front of your square term, we can deal with that if it is one of our 3 special forms, and we're going to be talking about that. We can also deal with it if it is a GCF. But other than that, we don't have a method of doing that. So you can kind of keep that in mind, but that's true for this course. It's not true for in general. Okay. All right, so no GCF. We have 2 terms, so that means we are looking for a difference of squares. First, we check the sign in the middle. It is a minus sign, which means it's a possibility. Now ask yourselves if you have perfect squares on the ends. Well, 9 is a perfect square. Its square root is 3 and an r. 3 squared is 9, r squared is r squared. 4 is also a perfect square. Its square root is 2. Now from our formula, this works as our a, this works as our b. Sorry, probably lowercase would be better. And so that means it factors as a plus b times a minus b. So this factors as 3r plus 2 times 3r minus 2. Okay. Let's look at this next one. 16r squared minus 25a squared. Look for a GCF. I have no a here, no r here, so no GCF on the variables. There's nothing that divides into both 16 and 15, so no GCF. We have two terms, so we look for a difference of squares. We have the minus sign, which is good. Now, 16 is a perfect square. Its square root is 4, and the square root of r squared is r. The square root of this would be 5a. So this works as my a, this works as our b. And so this factors as 4r plus 5a times 4r minus 5a. And to repeat myself, it does not matter whether you put the minus version first or the plus version first, because this is a multiplication and we can flip the order of multiplications.